29. We are almost home. 29 says 5 divided by y plus 3 is equal to 1 over 4y squared minus 36 plus 2 over 3y. So first things first, we always look for an LCD. What is our least common denominator? Now, on a first look, I notice that this one here is simplified, so I know my LCD contains at least a y plus 3, and then I see here this one also is simplified, so it also contains a y minus 3. So the only thing left is to factor out the y squared, 4y squared minus 36, and see what we get. Now there's two ways we can do this. We can immediately see that we have the difference of two squares, and we can factor it as, let's do this in green real quick, root plus root times root minus root. That's fine, but we're not done. We have to notice that this 2 and this 6 both have a 2 in common, and I'm left with y plus 3, and this 2 and this 6 also have a 2 in common, and I would be left with a y minus 3. So it would be 2 times that times 2 times that, or 4 times y plus 3 times y minus 3. Now that works. This is our factored form of this expression here. But we can also skip right down here and say, well, I know that 4 goes into both 4 and 36. So if I take the 4 out on the outset, I have y squared minus 9. And I still have the difference of two squares. So it'll be 4 times root, whoops, root plus root times root minus root. We get the same LCD in the long run, or the same factored form in the long run, which is to say y plus 3 is already represented, y minus 3 is already represented, so now all we need to account for is the 4. Alright, let me go ahead and erase some of this. Let's erase all of it. Let's erase all of it. And say that it's actually 4 times root plus root times root minus root. Okay, we got that. We're good. Alright, so in blue here, I'm going to multiply my LCD times 5 over y plus 3. My y plus 3 cancels with this y plus 3, and I'm left with 5 times 4 times y minus 3, y minus 3. Okay. In yellow, I am going to multiply my my 1 over that thing times the LCD, and I notice that every part of my denominator here cancels with every part of the LCD. So that's going to be just equal to 1. Alright, and in pink I'm going to do plus 2 over y plus 3, I'm sorry, y minus 3. The y minus 3's cancel, and I'm left with 2 times 4 times y plus 3. So this is 5 times 4 is 20 times y minus 3, and that's equal to 1 plus 2 times 4 is 8 times y plus 3. Now I distribute. 20 times y is 20y. 20 times negative 3 is minus 60 equals 1. 8 times y and then 8 times a positive 3. 8 times y is plus 8y. 8 times 3 is a positive 24. Okay. So I have a like term here and a like term there. So 20y minus 60 is equal to 25 plus 8y. Let's just keep this going. We are almost done. Almost done. Let's subtract 8y from both sides. And at the same time, we can add 60. And we're going to do that so we get the y's on the left side and my integers on the right side. So 8y cancels with 8y. 20y minus 8y is 12y, and that's equal to negative 60 cancels with 60. 25 plus 60 is 85. Now I solve for y by dividing 12 from both sides. Y is equal to 85 over 12. That doesn't look like it's factorable. I think that's done. And you can check the back of your book to make sure that's true. Okay, one last one. We are almost done. Number 31 says a over 2a minus 6 minus the quantity 3 divided by a squared minus 6a plus 9 is equal to a minus 2 over 3a minus 9. So we're going to have to do a little bit more work than we have been in the past. Whoops. A little bit more work than we have been doing. We want to know what the LCD is of this. And in this case, we're going to have to factor all these terms in order to get that LCD. This one just has a greatest common factor, which is 2. When I divide out 2a from, when I divide 2a divided by 2, the 2's cancel and I get a. Negative 6 divided by 2 is a minus 3. So I know my LCD will at least have a 2 and an a minus 3. Okay. Now this one here is a little bit more fun. I'm looking for factors of 9 that'll combine to give me, that'll combine, factors of 9 that'll combine to give me a negative 6. And that will be negative 3 and negative 3. Now, for those of you who have really gotten the hang of this factoring deal, you'll notice that when I have the first term is a perfect square, the last term is a perfect square, and if I take my roots and double them, I'll get that middle term. So a times a is a squared, negative 3 times negative 3 is positive 9, and a negative 3a times 2 is a negative 6. This is called a perfect square trinomial. A perfect square trinomial. And you're going to want to get to know that. So anyway, back to my great LCD. I know that I already have the 1a minus 3 here, but this one has 2 of them. So I'm going to need another a minus 3 in my LCD. And this one only has a greatest common factor, which is 3. And that's a minus 3 there. And this one only has one of the a minus 3, so we're good with that one. But I now need to account for this 3. So my LCD is 2 times 3 times a minus 3 times a minus 3. And let's do that. Let's multiply that all the way across our expression, our equation here. Okay, so a times 2 times 3 times a minus 3 times a minus 3 all over 2 times a minus 3 will have the 2's cancel and the a minus 3 cancel, and what I'm left with is 3 and the a and one of the a minus 3's minus. Now the 3, the negative 3, has both a minus, well, let's rewrite the whole thing. 2 times 3 times a minus 3 times a minus 3. Alrighty. Now both of the a minus 3's cancel here, so that's nice. And what I'm left with is that negative 3 times 2 times 3. And that's what's left there. Now on the other side of the equal sign, here's my LCD. When I multiply it by this fraction here, my 3's are going to cancel, and one of my a minus 3's are going to cancel. So I'm left with the quantity a minus 2 times the other a minus 3 times, times 2. And now I have to multiply everything out. I have to do my distribution. So here I'm going to distribute the 3a to the a and to the negative 3. So 3a times a is 3a squared. 3a times negative 3 is minus 9a. Minus 3 times 2 times 3 is 6 times 3, or 18. Now we'll do our, I don't like FOIL, but last time I said this kind of looked like a crab claw. So let's do our crab claw there. See that? Crab claw, the little pincers. So a times a is a squared. Now we have minus 3a minus 2a is a minus 5a. And the negative 2 times the negative 3 is a positive 6. And all of that's going to be multiplied by 2. So let's go ahead and simplify that even further. We've got, this stays the same. Nothing's going to change there yet. 2 times a squared is 2a squared. 2 times a negative 5a is minus 10a. And 2 times a positive 6 is plus 12. Now, a good indicator that I'm going to have to do something like set this equal to 0 is that I have squares. So let's see what happens when I move everything to one side of the equal sign. Let's subtract 2a squared from this side, right? And when we do that, let's move this all the way over here. Oops, where'd that come from? What are you doing there? What are you doing? All right. So 3a squared minus 2a squared. When I have 3 of something, I subtract 2 of them. I have 1 of them left, so a squared. I'm going to add 10a to both sides. Now, you owe me $9, and I have $10 to cover, so I'm left with $1 over. That's pretty nice. Those cancel to 0. Those cancel to 0. And now let's subtract 18 from both sides. I'm sorry, subtract 12. We're going to subtract 12 from both sides. Minus 12. Those cancel to 0. Negative 18 minus 12. If you owe me $18 and you borrow 12 more, now you owe me $30. And I like payment in full. Okay, so my new deal that I'm working with here is a squared plus a minus 30, and I can factor that. That's set equal to 0. That's factored. Now I'm looking for factors of negative 30 that combine to give me a positive 1. That should be too easy to find. It's a positive 6 and a negative 5. So a minus 5 times the quantity a minus or plus 6, that is equal to 0. So my factors are, remember the zero product principle means that either this number or this number is 0. So a minus 5 is 0 or a plus 6 is 0. This implies that a is equal to 5, and this implies that a is equal to negative 6. And we are done.